All right, here we are, 7.2, the magical quadratic formula. Woo! All right, this is yet another way to factor to solve equations that are quadratic in form. All right, and the formula is, and this is the quadratic formula as we know it, as we have come to know it. All right, and then you may ask, where about these ABCs? Well, where have we used the ABCs before? And it comes from the standard form of a quadratic equation, where you'd have something like ax squared plus bx plus c that equals 0. All right, here's where the ABCs come from that we substitute into the formula. Okay, you remember this, talking about this a little bit anyway. And so when we have quadratic equations, we want to make sure we put it in this form first. Notice the form. I've got x squared, it's descending order. It only starts at the beginning even, what am I trying to say? The even exponents that it would be if it's quadratic in form. But that's the idea of it. Okay, so let's put up an example. And I'll leave that to match it. So let's see, our first example is x squared minus 5x, not 6, minus 5x, and then that's minus 6, that equals 0. All right, there's my ABCs. So A is going to equal what number? 1. B is going to be negative 5, and C is going to be negative 6. So you could invariably list those numbers if you want. You find your own way of doing it, but I could say that A equals 1, B equals negative 5, and C equals negative 6. And then I could plug it into the formula where I'm going to have negative B. So negative B is going to be negative 5 plus or minus the square root of B again, which is negative 5 squared, minus 4, part of the formula, times A, which is 1, times C, which is negative 6. And that's all over 2 times A, and 2 times A is like, A is 1. There. You can plug all this into your calculator and get your answer if you want it in one shot. Let's see what we come up with. Well, one problem I want to show you, yet I'm not able to because I don't have the calculator on the screen to show you. So I'll just kind of walk you through it here with the assistance of the calculator if and when I need it, okay? All right, so at the beginning we had negative 5, which is positive 5. Whoop. Let me do this, okay. And then, as a matter of fact, I'm going to change color here a little bit, make it a little easier for you to see or understand. So here I had negative 5, and that part there is going to be positive 5. I do the numerator first, then divide it by the denominator. All right, then notice I have plus and minus, so I'm going to do these one at a time as well. It should go generally pretty quick though. All right, so I've got 5, and then let's say we do plus. And then how about the square root of all this? So in the square root sign, I'm going to have 25. That's the negative 5 squared. And then I got negative 4 times negative 6 is positive 24. And then times the 1 would still be positive 24. Okay. And I can see that 25 plus 24 is 49, and the square root of 49 is 7. So that makes all this is going to be a positive 7. All right, this is gone. And then I'm going to divide this by 2 times 1, which is 2. So I got 5 plus 7, which is 12, divided by 2 is 6. So one of my answers is 6. Okay, the other answer I'm going to get is probably by just changing the plus sign here from a plus sign to a minus sign. And let's do this in red, minus sign. That's my next job to do. And all that means I'm going to do is I'm going to have 5 minus 7. 5 minus 7 is negative 2, divided by this 2 times 1 is still 2. And my answer there is negative 1. So my other answer is going to be negative 1. All right, I'm solved for it. All right, on this particular problem, I could have, and you won't always be able to do this, of course, but it's if you have x squared minus 5x minus 6, then if this is quadratic equation, it's already equal to 0. I could factor this in the traditional ways that we know how already. All right, so that means I'm going to have what? I'll have my 2 parentheses. I have x minus plus, and then my 2 numbers are going to be 6 and 1. That equals 0. So here I've got x equals 6 or x equals negative 1. And the same answers that I had using the quadratic formula. All right, so there you have it. Let's go on. We have several examples for me to go through with you. Okay, here's example 2. And this is almost in the right form. So what is it I have to change? I have to move everything over to the left side, get the equation equal to 0. And there's my result, 2x squared plus 4x minus 3. And now from here, we want to use our quadratic formula to get everything in order. All right, and what will that look like? That's going to look like negative 4, which is b, and then plus and minus the square root of b squared. So I'm going to, not yet, b squared minus 4 times a times c. And c is negative 3. There. Okay. All divided by 2a, and 2 times 2, well, and eventually will get me 4. So there's the problem. All right, practice along with I won't even bother with the calculator, except for simple addition. So I'm going to have negative 4 plus first. I got to do both, plus, then minus for my 2 answers. Then I'm going to get what? 16, a little sidebar here. And I'm going to have 16 here for the 4 squared. Plus, because this is negative 4, this is really important, times negative 3. Negative 4 times negative 3 is 12. Positive 12 times 2 is positive 24. Okay, and then the square root of 20, 30, 40, the square root of 40. Square root of 40 divided by what? 4. All right, so there's the problem. Now this is more manageable to put into your calculator. So I'm going to do the numerator first. All right, so that's going to be negative 4 plus the square root of 40. I don't have to simplify that or anything. I'm in the hunt for the answer. And let's do that. I'm gonna stop there. I'm just doing the numerator. Okay. That gives me a decimal of 2.32455. And then I'm going to divide that by 4. Divided by 4. And that gives me another decimal number. Don't know if I like this idea because, well, I'll tell you why. Because our answer has to be in exact form. I can't have it in decimal form. Okay, so I have to go back and do that square root of 40 and simplify it. Okay, so what a lesson there. All right, so if that's the case, then remember I'm only on the first part as well. So I'm going to have 40 is 10 times 2 times 2, and this is 5 times 2, which the 10 is. All right, that's on that. So there it is. So I've got the square root of 5 times 2 times 2 times 2. All right, and it looks like I'm going to have 2 of the same number comes. I have 2, 2, so 1 comes out, and then I have left over is 10 inside. So what I have this to simplify is going to be not square root of 40. I'm going to change that and put it down as the square. I'm going to put it down as 2 root 10. Okay, let's do that. So now what have I got here? I can split this up is what I can do. I can rewrite this to be negative 4 over 4 plus 2 root 10 over 4. All right, let's say we did that. Then I'm going to have negative 1. What happens here? 2 goes into 2 once, 2 goes into 4 twice. So then I'm going to have plus root 10 over 2. Okay. I'm checking too myself. Negative 2 plus or minus 10 over 2. Well, I've got a problem here with this. I have a negative 4 here. And where'd this 4 come from? I split it up there, that 2 times 2, which is on the bottom. Oh, it's no worries. It's how they calculate this. This is equivalent to what they have in the book. And if I added these two up, the negative 1 plus root 10 over 2, well, I'm going to make the denominators the same. This is really negative 1 over 1, right? So if I multiply top and bottom by 2, then I get the negative 2. So the answer that they have in the book of negative 2 plus root 10 divided by 2 is our answer. That's all we can do. And this would be over 2 as well. Another alternative way of writing that would be this. Another alternative way of writing it like this. These are correct so far. It would be negative 2 plus or minus root 10 all over 2. And that's what they have in the book. So I have negative 2 plus root 10 over 2 and negative 2 minus root 10 over 2. So you'd have to split those up and get the answer so you plug it into your homework assignment correctly. So in the homework, I believe they want negative 2 plus root 10 all over 2. And then the other answer is negative 2 minus root 10, and that's all over 2. So these are the two solutions that they're looking for that particular problem. Okay. All right, let's try another one. By the time we're done, we should be knowing how to do these. Next problem. Okay, here's example 3. And you can see it's not equal to 0, so I'm just going to get that negative 7, add 7 to both sides, and bring that over to the left side. All right, and that's going to give me what I need of x squared minus 6x plus 7, and that's going to equal 0. Okay. All right, let's put it in our proper form. with the quadratic formula, where I'm going to have negative b, so it's going to be negative 6. That's what you got to watch out for in our brain. It kind of fools us a lot of times. So I'm going to have negative b plus or minus this square root of b squared. So b squared is going to give me 36. And since it's squared, it's always going to be positive here in the front, underneath the radical sign. All right, so I got 36 minus 4 times a times c. So a is 1 and c is 7. You can do it on the fly if you want, when you're confident in your mathematics or adding and subtracting and multiplying and dividing skills. That's always nice. And then I got, so it's 4 times a times c, and all this is over 2 times a, but a is 1, so it's just 2. Okay, let's work this out now. This time I've got 36 minus 28. 36 minus 28. What is that? 8. All right, so I got the square root of 8 here. So let's rewrite this and see if we can organize ourselves. So I got 6 plus the square root of 8, which is 2 root 2, and that's all over 2. So I'm going to put the 2, I'll try it here. See which way you like doing this. So now what I could actually do here is I could put the 2 under each of the terms, and let me just erase that so I can show you that I'm putting the 6 underneath this 6 and the other 6 underneath the 2 root 2, which is perfectly fine to do. All right, and then I'm going to have what? 6 over 6 is 1, plus or minus, in this case. This 2 over 6 now I can simplify. 2 goes into 2 once, and 2 goes into 6 3 times. And then I'm going to have left over is root 2 over 3. And do they have it that way? Their answer is one step above. So either one is correct. Either one of these, 6 plus 2. 2 root 2, 3 plus or minus. Oh, they have it a different answer, though, again, where they're adding these two. This would give you 3 in the denominator if I multiply the top and bottom by 3. So either, well, I don't know on your program there. That's going to be exciting. So I'm getting my denominators to be the same, and then I'm going to end up with 3 plus or minus root 2 over 3. Is that right? Okay, I had 2 over 2. I'm just checking out my own work here. And it looks like I'm pretty doing okay with that. And you can always check it. 3 plus root 2, but it's an equation. I don't, yeah, we're solving for x, so I don't need the 3's. So this would be my answer here. 3 plus or minus root 2. We're solving the equation. I don't need the denominators of those 3. They ended up canceling out. You can see they're easy, but yet they are problematic in how we answer it. It's got to match our answer that we do on our homework program. That's my main concern right now. All right, so look that example over and look at what we're doing. I'm glad I'm doing the examples now. And it's like 3/4 of the way down on page 597, where I match that. Then it's the simplifying problem. It becomes, how do I simplify that? And notice what they did. This is worth talking about. All right, I was with them as far as matching the way they were doing it at the point of 6 plus or minus 2 root 2 all over 2. And instead of splitting it up like they did, they factored out the 2 here from the 6 plus or minus 2 root 2. So on the top here, you can take out, I'm going to erase that for a moment, and if I'm going to factor this, even though they're numbers, I don't have variables involved, I could take out a 2. And if I take out a 2, then I'm going to put back what? 3 plus or minus root 2. And that's all over 2 times a, which is 2. I'm putting back that denominator. And now here, what happens is the 2's cancel out. And then you're left with 3 plus or minus root 2 as your answer. Okay, so since we got wind of that, I'm going to try to do it that way. Instead of separating them like I had, if I took this part here and divided this by 2 and this by 2, then I had 3 plus or minus, watch, I don't know why I'm in such a hurry, 6 plus or minus 2 root 2. Okay, and then if I divide, remember I had a 2, it was all over 2. But I'm going to put the 2 here and the 2 here, which I was suggesting to do earlier. And I end up with the same thing. 6 divided by 2 is 3, plus or minus, the 2's cancel out here, and I've got the square root of 2. So that's my whole point about this. Okay, next one. Let's just keep doing them. Keep doing them. That was 3. How about example 4? Okay, herein lies example 4. And this example 4, because it's example 4 here, I want to erase that and put down, what do I want to do here? I've got it equal to -1/2, so I know I can take care of that later. But first I want to clear the problem of the fractions. Let's get rid of these fractions. Okay, and a nice way of doing this is by multiplying everything by the LCD. And the LCD here is 10. Or I could get all my denominators to be the same as well. All right, so whatever your choice is. I'm going to multiply everything by the LCD. That means I'm going to multiply this first term by 10. That's 10 times 1 over 10, x squared. I'm going to multiply the 1/5 by 10. And then I'm going to multiply -1/2 by 10. All here. And then I'm going to put these in boxes. I kind of lose my mind looking at this stuff. Okay, and then one at a time I'm going to simplify these. So these 10's just cancel, and I've got x squared left over. 5 goes into 10. 5 goes into 5 once. 5 goes into 10 twice. Then I've got 2 times 1 times x, which is -2x. And then how about, can I bring over, no, I won't. It's going to be equals, 2 goes into 10 5 times, and 5 times -1 is -5. So there, I got rid of all the fractions are gone. Now I'm going to put it in standard form by writing it up as x squared minus 2x plus 5 equals 0. And what I did was I added 5 to both sides. All right, now I've got it in the right form, the quadratic equation's in the right form, and now I'm going to apply the quadratic formula. All right, so let's go. I've got -2 plus or minus root b squared, which is going to give me 4, minus 4 times a is 1, and c is 5. That equals 0, and this is all over 2 times 1 is 2. That's what we've got so far. Okay. Okay. So now it looks like I'm going to have 2 plus or minus And now here I've got a little problem here. I got 4 minus 20, it looks like. 4 minus 20. Well, that is negative 16. And the square root of negative 16, remember, I can do this now. It's going to be 4i. All right, so I got plus or minus, and then this up here, 4 minus 20 is negative 16, is going to give us 4i. Okay, and that's all going to be over 2. And now if I apply what they did earlier, I can factor out the 2 on the top here. If I factor out the 2 on the top, I've got 2 on the outside. If I put back what's left over, I'm going to have 2 divided by 2 is 1, plus or minus 4i divided by 2 is 2i, and that's all over 2. Now the 2's will cancel, and this is all going to equal 1 plus or minus 2i. And we're good. X equals 1 plus or minus 2i. And that's our answer. 2 answers, really. 1 plus 2i, 1 minus 2i. All right, and that there was example 4. Okay, here's example 5, and it looks pretty challenging here because it doesn't look like A, B, or C's are involved here at all. But we do know we can multiply these together, and that's what I want to do. I want to multiply the left side, these two binomials, by foiling, and then bring over the negative 4. So it equals 0. How about it? 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Inside is negative 3 times 2x, which is negative 6x. And negative 3 times negative 1 is positive 3, which equals negative 4. All right, let's combine our middle terms here, our like terms, and I've got 4x squared minus 8x plus 3 equals negative 4. Okay. I'm there almost. I just got to add 4 and get it equal to 0 by adding 4 to both sides. And I end up with 4x squared minus 8x plus 7 equals 0. Now let's plug these numbers in for the quadratic formula. A, B, C. Okay? All right, so A is 4, so it's going to be negative 8 plus or minus square root of B squared, and that's 64, minus 4, part of the quadratic formula, times A times C. Okay. And that's all over 2 times A, and A is 4. All right, so let's figure this out. I'm going to figure out what's under the radical sign. And I'll use my calculator for that. I got negative 48 underneath there. So let's see, I'm going to have positive 8 plus or minus the square root of negative 48 all over 8. This is where I'm at thus far. I've got to simplify the square root of negative 48. All right, so let's see, what would that be? I've got 12 times 4 is 48. 2 times 2 here, and the 12 would be 2 times 2 times 3. All right, So for every, I got the square root of this now, right? I know the negative, so the I is going to come out. And then 2 2's are here, one comes out. 2 2's are here, another one comes out. So this isn't 2i, it's 4i. And then what's left under the radical is the square root of 3. All right, good with that. So let's reorganize a little bit and write this up as 8 plus or minus 4i root 3, all divided by 8. Okay. Factor out the 4 here in this numerator. If I take out the 4, I'm going to have left is 8 divided by 4 is 2, plus or minus what? I root 3. And that's all over 8. And then you can see that they have 4 over 8, so we can simplify that. So 4 goes into 4 once, 4 goes into 8 twice, and it looks like I'm going to have 2 plus or minus I root 3 all over 2. And that's the way we're going to leave our answer. So remember that when you're doing your problems from the homework, we're doing the factoring part here, so our answers match the way they're doing it in the book. That's really helpful. All right, next. All right, here's a different looking problem because it's not quadratic in form. So it looks like it would be a mistake for us to solve this for t by adding 8. If I added 8 to both sides, then I'd have 27t cubed that equals 8. And then from here, I guess I could divide both sides by 27 to get the t. I'm working on getting the t by itself. And then I'd end up from here, I'd have t cubed equals 8 over 27. And then I could take the cube root of both sides. Cube root of both sides. Then I'd end up with t equaling, well, the cube root of 8 is 2 over the cube root of 27 is 3. Okay, that's real enticing to do, but this only gives us one answer, one solution. This t to the third power indicates that we could have up to 3 answers. Okay, so this way of doing it is not correct. So I've got a feeling what we're going to have to do is factor this 27t cubed minus 8 that equals 0. So we can factor, that's the difference of 2 cubes. Okay, so we got to put our memory cap on to say, how did we do that? And the way we did that was we took, let's see, what do we have here? I'm going to take the problem itself. So I had it came from a binomial times the trinomial. And then my next order of business was to set up my signs. So SOAP is coming back to my head. Same sign as the problem, then opposite, and then always positive. So those are the signs of my numbers. And then what's going to go here is the cube root of 27t cubed, which is 3t, and then minus 2. And then here, the rest of the way, I'm going to square the 3t. That is going to give me 9t squared. Then in the middle is going to be 3t times 2, which is 6t. And then I'm going to square the negative 2 to give me 4. All right, so we factored that correctly. Remember, this is equal to 0. Now on this difficult problem, notice I've got 3t minus 2 here. So I could just do my normal factoring with this binomial here, which we usually do. There's nothing special about those. All right, so this is going to be what we did already earlier, where I did it up here. We ended up with t equals 2/3, and that's one of my answers here. So if I set this 3t minus 2 equal to 0, then I'm going to add 2 to both sides. And I've got 3t equals 2. Divide both sides by 3. And there's your t equals 2/3 a second time. But we just want one time. All right, so that takes care of that. All right, this portion of the problem. Now I've got this trinomial here that I want to factor. Okay, and I've got to do it by the quadratic formula. All right, so we have 9t squared, and that was what? Plus 6t and plus 4. That equals 0. And I'm going to use the quadratic formula for that. And how about it? So I'm going to have negative b, which is negative 6, plus or minus the square root of b squared, which is 36, minus 4 times a is 9, big number, and c is 4. Okay, and with the aid of the calculator here, I'm going to say, what is this going to be? How about 36 minus 36 times 4? So I've got negative 108. All right, so far I'm reorganizing. Remember, I got my denominator to do here too. And I'll put it here in a moment. I'll put it over 2 times a, and that's 18. All right, so here I have negative 6 plus or minus square root of negative 108. That's my problem thus far. All right, the negative 1 is going to be the I, not this one, just the fact that it's negative 1 times, I'm sorry, it's going to be I times the square root of 108. So let's take this 108 and determine what our square root of that is. All right, so I've got 54 times 2 for starters. 54 breaks down to be 9 times 6. 9 is going to be 3 times 3. The 6 is going to be 3 times 2. And then I'll bring this 2 down here for my other 2. So I've got the square root of all this. Okay, and what? So every I got 2 3s, 1 comes out. I got 2 2s, 1 of the 2s comes out. So it's going to give me 6. Okay, and my 6 is going to be here. And what's inside is the 3 left over. 6 root 3, that becomes. All right, so I'm going to scoot over here a little bit and write that up as negative 6 plus or minus 6i root 3. And that's all going to be over 18. Okay, carrying on. I'm going to factor out the 6, and I'm going to factor out it doesn't matter, I could take it with me. I'm going to factor out the 6, and then I'm going to put back, what? Negative 6 divided by 6 is negative 1, plus or minus. 6 divided by 6 is 1. Or I could just say I. 1 times I is I root 3. And that's all over 18. So I can simplify that a little bit more. 6 goes into 6 once, 6 goes into 18 3 times. So I'm going to end up with -1 plus or minus I root 3 over 3. And it looks like we've got it. That's a little bit of a toughie, but manageable if you break it down, and really organizing yourself, it helps too. All right, here we have a couple of, what shall we call those, application problems. All right, let's do the one here. How about that? I'm going to give you this one about the object thrown with an initial velocity of 20 feet, example 7. All right, and example 7 is about this application. If an object is thrown downward with an initial velocity of 20 feet per second, the distance s of t in feet it travels in t seconds is given by the function s of t equals 20t plus 16t squared. How long does it take the object to fall 40 feet? Okay, here's the main points of this problem, where they give us the function, which is a blessing, all right? And it's saying that the function is s of t. Many times this s of t is the variable h, meaning height, okay, at a certain time. But now they're just labeling the function to be s, and it's all about, with respect to t, the time it takes. All right, so it's saying how long does it take the object to fall 40 feet? Well, the 40 is going to go where the s of t is. I'm going to plug that into it in that way. All right, so how about I replace that? 40 equals 20t plus 16t squared. And, you know, in these problems, most of the time they give us the equation. For the most part, we just have to substitute how high it is at certain times. That's the question. That will be the question that you'll get. All right, so invariably, here is our problem now. Okay, it's quadratic, so I got to get it in the right order. So let's see what I can do. I know I can subtract 40 from both sides. And if I do that, that's okay. I'll just rearrange it in the right order. So it's going to be 0. I like the 0 over here on the right side. And that's going to equal the 16t squared is first. And then plus 20t. And then minus 40. Yeah. Minus 40, that equals 0. How's that? And now it's set up this way. I can use a quadratic formula to determine how much time it takes for the object to fall 40 feet. So let's do that. So here I'm going to have negative b, which is negative 20, plus or minus. And let's do this square root business here. I'm going to have 20, or b squared, which is 400, minus 4 times a, which is 16, and times c, which is negative 40. Okay, and that's all going to be over 2 times a, and a is 16. Okay, we're on our way. And let's try it. Let's take care of the radical first. So I know I'm going to have negative 20 plus or minus, and then let's see what we come up with here. How about, oops, I'm going to go 400 minus 4 times 16 times negative 40. And all that ends up being 2960. Is that a perfect square root? I don't think so. That's an application problem? No. All right. However, we're talking about time here. So if we're talking about time, then I think it's going to be okay to use our decimal answers. Because if I said, well, it took 3 seconds for it to reach 40 feet. So, or I could say 3.5 seconds, or t equals 3.5, this way. That's much nicer than to say, well, it took 7 halves of a second. You know, we don't understand that in that sense. Or I could say the time that it took was 3√2 seconds. See, we don't speak that way. We tell what the time is in numerical form. All right, so that's why I think it's okay to just plug it in and use our decimal number for an application problem that's referring to t. The other problems they're just arbitrary kind of quadratic equations that we are not allowed to use decimal numbers. But in this case, I think it'll be okay. All right, so then that tells me that if I look at 2960, and that's the square root of 2960, all divided by 32. Well, this is where we're at now. And give me a second. I want to get rid of this here. I don't like clutter. It confuses me. All right, but let's say we calculate this as it is. And let's determine what it comes up to be. Okay, plugging these numbers into my calculator, I come up with two answers. One is 1.08 seconds for the object to fall 40 feet, and the other is -74. Well, time cannot be negative, so this one will discount. We will not use that at all because it's impossible. So we have one answer, and that answer is going to be 1.08. And that is our solution for that application problem. And that's the one you can probably expect as far as our applications go. All right, that's it for today. I thank you. And there is, if you have the TI-83 or 84 calculator, there's using technology section on page 601 that you may want to pursue if you like. Makes things a little easier, or just the scientific calculator is fine too as well for determining these numbers. Be careful with the square roots of negative numbers. You know, the I is involved. So, and also critical is the idea of factoring. When we factored out those numbers, it seemed to work out better than doing what I originally was saying to do, to separate them. Okay, that's it. We'll talk to you soon.